So, um, yeah, I'm gonna do my homework, and that's what I'm gonna be streaming. Why? I have no idea. Just cause. And yeah, we'll start. Well, I'll start. Not will. I will. And yeah, I have no clue why I'm doing this. What is wrong with me? What is wrong with my life? I don't even want to do my homework. It's already 10. I'm probably gonna finish like at 12, so it's probably gonna be like a 2 hour stream. Probably the reason I'm doing it is because I want to talk, I guess. So that's literally the only reason I'm doing this. Probably the only reason I'm doing this. And just because I thought it would be kind of funny, I guess. I mean, like, who does this, right? So yeah, I'm like, why not? Why the fuck not? Let's see, let's share it. Let's share this shit, mate. Let's share this shit, mate. So, I've already done my English homework, and I have my biology homework now. So, you know, biology is kind of like the hardest one, I guess, is what I have to do right here. It certainly is the most tedious one and the most time consuming one. Nobody's even watching yet, so that's kind of funny, I guess. That is quite funny, honestly. But yeah, I mean, I don't even know. It's just what is going on, man. Oh look, there you are, just saying, what's up? You have an assignment? Same. Wait, what am I lying in? What did I lie about? I'm so confused. See, now I'm gonna put the live chat here so I can keep on looking at it. Hopefully not get too distracted. Ew, I do need to change that picture. Ew, look at that acne. Ugh, ugh, ugh. I mean, I still look disgusting, but it echoes. I have no clue why it would echo. Honestly, no clue. Is it still echoing? Is it like constantly echoing, or what? What's going on? I don't. I really. I. I don't know honestly. Mm, ¿Qué? Ya, no, no sé, lo terminé. Terminaron siendo 243. No, tengo que hacer esto. No sé si quieres guardarlos en el refri, ¿no? Mejor, yo digo. No, está ahí en el refri. Oh, thanks. And no, I'm not compensating anything. I'm just, I don't know, I just doing it because. ¿Eh? No, pues no te escucha. Wow. So I have to read. 301, 3.3. I don't know. Maybe some other day. Some other day. Some other day. There'll be a different stream. I need a pen. Oh, here's my pen. Wait, no, I don't. That's not my pen anyway. I'm gonna take out my biology notebook. Here we are. Write down the notes. Boy, you gotta take them notes, boy. What you know about notes, boy? Wow. You. Don't say that to my beautiful backpack. We've been through a lot together. Should I read these? These. I always do it. Oh, it's right here. I'll stretch them the other way. Should I read it out loud or nah? Should I read it in silence? That'd definitely be more awkward to do it in silence, but I think that's good. So should I do it in silence or should I do it out loud? I don't know. You guys decide. Vote on it. Damn. Chill. Why not read it out loud? I'm not used to reading out loud, but I guess I'm probably gonna mess up a lot. See, I don't play music when I do this, but I don't want to get I don't want to get my live stream taken down because of copyright. So I don't think I should do that. So I think I'll just leave it like that, like no sound, just myself. Or should I put some? Nah, I don't want to risk it. Do you remember me? How we used to be? Don't you should be. No, I don't have Twitch. I mostly use Mixer because it's already integrated with Microsoft or YouTube to do like on my computer. I could do Twitch, but I mean, who's gonna watch that honestly? I'm live streaming me doing my homework, okay? People want to watch me do my homework so they know I can succeed in life and that I'm making something good out of myself.
And what part is that?
Song request?
A song
Yeah.
request? If we do song, can you get copyrighted?
Yeah, I could get copyrighted. That's why I don't want to put music. It's not letting me share it on my Snapchat. Like, the link don't want to work.
Can you just say the song doesn't belong to me, it belongs to its rightful owner, and then they won't copyright you?
Nah, that's not how it works. That's some bullshit that they do, but it don't work.
Copyrighted just cancel. It doesn't. Now it's like gonna die.
Okay, so the link does work, right? Because it worked for you just then, yeah.
Yeah, I'm not blonde.
So it should work. I'm surprised there's actually people watching this. Play some
People
free
actually
music.
enjoy watching people.
Yes, they enjoy watching me do my homework because they want me to succeed in life and they want me to be great and do great things. Yes, they do. They want me to succeed in life. What the fuck is that? Okay, let's actually start. Okay, let's. Okay, I guess I'll play some music in the background. Fuck it, fuck it. If we get taken down, I guess it'll be alright. It'll be alright. Let's see, what can I play that doesn't like distract me too much and it's not too bad. I'll just play some Pink Floyd. Alright, hold up. We'll play some animals. I'll play it from my speakers. Oh, wrong one. I know you guys can't hear it, but I'll fix it in a second. Right? I should be able to do this. No? Not at the camp. Oh yeah, there we go. That doesn't work though. Since I away. Okay, so it's not working. No, it's not working. I don't know why. I honestly don't want to figure it out right now.
Since I'm bored and I can't use my phone, and then I'll actually do it.
Why can't you use your phone?
Oh shit, I need to charge it. I'm gonna need to charge it.
I'm trying to figure this out, guys. Maybe real quick. Hold up.
Is my phone smaller or bigger than yours? Or are they the same size?
I don't know. Yeah, you still can't hear it. I don't know. I don't know, guys. I don't know what to tell you. We'll just leave it like that. I guess no music for you guys.
Can't you listen to music and not make them listen to music?
Yes, I can listen to music, but I wanted to make them listen to music to me because they asked for it.
But what if they don't like your music?
Ew. Well then, too fucking bad for them.
You listen to Pink. Ha 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 ha.
It's Pink Floyd with Pink. Man, we'll just leave it like that because apparently y'all can't hear it. So, okay. So I'll start. As you learn, biological macromolecules are large molecules necessary for life. They are built from smaller organic molecules. There are four major classes of biological macromolecules: carbohydrates, lipids, proteins, and nucleic acids. Each is an important cell component and performs a wide array of functions. Combined, these molecules make up the majority of cells' dry mass. Why?
Because I have never got to see it.
Okay. Pero bájale o ve a la sala. But you bring it back after that.
Do I unplug it?
Yes, just that video. Oh, my sister wanted to watch my animation. Anyway, I don't even know. Can you even see me? How's the camera? Let's break it down a little bit. Okay. So right now I just have to read, I think. Yeah. Holy shit, I have to read a lot. Okay, I better get this going, guys. I need to get this going. Biological macromolecules are organic, meaning they contain carbon. In addition, they may contain hydrogen, oxygen, nitrogen, and additional minor elements. So we're gonna write what macro biological. Sorry about that, guys. I'm seriously putting a number in my stomach. Anyway, we're doing 3.1, and we're gonna write what biological macromolecules are. You know, this. I feel like this would actually be cool, like watching it if you have like the same classes and shit, and you need to learn this. Like it's like having a study buddy, you know? Like I'd watch someone to do my shit. Large molecules necessary for life, and they're built from small organic molecules. Yeah, I read kind of slow. I and I read like shit anyway, which kind of fucked up. Some people like they write so fast and they write so nicely. I envy them. What the fuck? I thought I had lost my yellow highlighter. I generally what's it called? Words that I need to know. What the fuck are they called? I can't think right now. Vocabulary words, I highlight in yellow. Okay, so now dehydration synthesis. Once macromolecules are made from single subunits or building blocks called monomers. The monomers combine with each other using covalent bonds to form larger molecules known as polymers. In doing so, monomers release water molecules as byproducts. This type of reaction is also known as dehydration synthesis, which means to put together while losing water. Monomers, so made from single subunits. Okay, so monomers, and they combine with each other. Yeah. Pink highlighter is for what is pink highlighter for again? Oh, for roots.
Is universal life insurance a good idea?
I don't know. I'm not here to discuss fucking politics right now. But
Not life.
it is life. It's just behind by a few seconds. Okay, monomers. Okay, back to this. Monomers combine with each other to form polymers. And they release water while doing so. Okay. I guess next paragraph. I just need to highlight monomer and polymer. There we go.
Song requests, yes.
Yeah, I have a webcam. What are you not? That's right. Oh wait, it's a. You mean like no? It's a laptop's webcam. It's not like a separate webcam.
He doesn't have enough money.
Yes, I do. I could buy one, but why would I buy one when my laptop already has one?
What do you use a laptop?
And para qué quiero una webcam if I don't have shit to use it on? I don't know. My sister's saying some stupid shit, man. Okay.
His face sounds weird on the video. I'm giving you a view. I'm grateful.
In a dehydration synthesis reaction, the hydrogen of one monomer combines with the hydroxyl group of another monomer, releasing a molecule of water. At the stop distracting me, Atara. The hydrogen of one monomer combines with the hydroxyl group of another monomer, releasing a molecule of water. At the same time, the monomers share electrons and form covalent bonds. As additional monomers join, this chain of repetitive monomers forms a polymer. Different types of monomers can combine in many configurations, giving rise to a diverse group of macromolecules. Even one kind of monomer can combine in a variety of ways to form several different polymers. For example, glucose monomers are the constituents of starch, glycogen, and cellulose. Glucose monomers, okay. Hydrolysis. Polymers are broken down into monomers in a process known as hydrolysis, which means to split water. Oh my god, this really needs like... Wow. Dang, somebody called me a loser. I'm sorry. Okay, I'm not hurt anymore. I recovered. To split water. So polymers broken down into monomers. It's called hydrolysis. And it means to split water. Don't you have school tomorrow, Atara? Shouldn't you be sleeping though?
I can sleep at whatever time. I still wake up at the time I need to wake up.
So there I just highlighted hydrolysis. Needs more, yeah, I agree, Sterling, but that's something I cannot provide.
Needs more what? What is it in more mean?
A reaction in which a water molecule is used during the breakdown. During these reactions, a polymer is broken down into two components. One part gains a hydrogen atom, and the other one gains a hydroxyl molecule from a split water molecule. Okay, so one part gains a hydrogen atom, the other hydroxyl molecule. And we'll highlight that in orange because that's actually other important shit. That's what I highlight. That's what I use orange for. Yeah, I haven't. My class is at 9:30, I think. No. Wow. Well, Sterling, you're in the wrong place for that.
I'm out. It's the disgusting. People are disgusting when they're ready to talk. You say to them to make them think.
Ya vete a dormir.
No quiero.
What's his name? I completely got lost. I lost my train of thought. No, I know where I was. Oh yeah, okay, so whatever. Dehydration and hydrolysis reaction are catalyzed or sped up by specific enzymes. Dehydration reactions involve the formation of new bonds requiring energy, while hydrolysis reactions breaks bonds and release energy. The reactions are similar for most macromolecules, but each monomer and polymer reaction is specific for its class. For example, in our bodies, food is hydrolyzed or broken down into smaller molecules by catalytic enzymes in the digestive system. This allows for easy absorption of nutrients by cells in the intestine. Each macromolecule is broken down by a specific enzyme. For instance, carbohydrates are broken down by amylase, sucrase, lactase, or maltase. Proteins are broken down by enzymes pepsin or peptidase. And by hydrochloric acid, lipids are broken down by lipases. Breakdown of these macromolecules provides energy for cellular activities. And that's chapter 3.1. Well, section 3.1. And then we just have 3.2.
Synthesis of biology of macromolecule.
Oh, because I like the book, and I already bought it, so might as well. Wow, thank you. I take compliment to that, and I admit I am a huge nerd.
Believe it.
I take pride to it. I'm a proud nerd.
Be a video game nerd.
Gross? You're gross. Yes.
If she thinks it's gross, why don't you just leave?
Down. My sister said, "Why don't you just leave if you think it's gross?" Down. My sister roasting people over here. What the? I'm gonna take a quick break since I just finished a chapter. Not really a break. I'm just gonna check my phone.
For any Jasmine text.
Just to everybody. Oh, there you are. Importa.
Did she left?
I don't know. There's two people watching.
Beaks.
Anyway, um, okay, so I just have to write down about hydrolysis reaction. They are catalyzed by specific enzymes.
Wednesday, you can leave the house until Angel gets here.
Why?
Because I'm going to church Wednesday. Until Dad gets here and
The fuck you mean? I have school.
No, I mean, I know you're getting here early, but I'm just getting here like at 40.
Okay, so hydrolysis reactions.
Here in the house.
I can do whatever I want, girl. What the fuck? ASMR. I don't think this mic will really work for ASMR, but it should. Does it? Are you having a lot of ASMR? You know, a lot of ASMR.
Disgusting.
What background noise? There's background noise? I don't even know what it is, honestly. I will fix it, but guys, I'm just learning how to stream, so I don't know anything about this shit, man. And plus, yeah, this mic sucks, man. This is like a really cheap headset that I got to play Xbox.
You did not get that headset.
Yes, I did. I got the first one and he broke it, so. Tingles. I'm glad you had them, you know? Having a great job.
What's tingles?
You know, yeah. You don't know what tingles are? Come on. Okay, ya. Me están distrayendo mucho. A ver. Catalyzed.
You're the one screaming.
But you're the one who's distracting me mainly.
I'm a distraction.
I know. By specific enzymes. I'm actually surprised people are watching. I just did this because I thought it'd be funny. Like as a joke, you know, haha, so funny, I know. So original, but and I think people are actually gonna watch. Neither stick around, but I'm glad you guys did.
Are you sure these kids are in college?
Yeah.
Brio, what is that?
What?
Brio.
He meant bro. Chill. The I is next to the O. I thought I stop for real. I'm not even kidding. Yeah, usually I get very distracted with my biology homework, so it takes me like 2 hours to do it, 3 hours at times. Okay, so by specific enzymes, and then we just have to write that Dehydration that requires energy. Dehydration is with a Y, so I was right first. Forming new bonds. So it requires energy. On the other hand, what was the other one? Hydrolysis. Hydrolysis breaks bonds instead of making them, so it releases energy. Yeah, well, I guess too boring. That's not entirely true. I have homework due tomorrow. Yeah, it was kind of a joke because I was like, I've never seen anybody do it. Probably people do. I mean, it's the fucking internet. There's nothing original. But yeah, I was like, like, dude, like, who would do this? I would do it because I've been streaming a lot lately. So I would be like, you know, living that streaming life. I should set up a fucking donations page so y'all could give me money while I study. You know, be like, good job with that hustle, and y'all could push me on. You know, this is an entrepreneur mind. You know, I'm making a business out of studying.
Don't you want to be a doctor?
So I could be an entrepreneur still. Oh my god, what the fuck?
It's B. It's a letter.
There go 3.3. Oh my god, I still have a lot. Especially with 3.3. Jesus, nah, it's not that much. Because most of them are small pages.
The only person I don't like from here is that white guy. This sterling white teacher.
He's just joking, chill at that.
I don't like his jokes. Unfunny jokes.
Yeah, okay. Te quitó el teléfono papá, right? That's why you're over here bothering me. Then what the fuck? Just go! Okay. Section 3.2. Carbohydrates.
And I did my homework, so.
Okay. Most people are familiar with carbohydrates, one type of macromolecule, especially when it comes to what we eat. To lose weight, some individuals adhere to low-carb diets. Athletes, in contrast, often carb load before important competitions to ensure that they have enough energy to compete at high level. Carbohydrates are, in fact, an essential part of our diets. Grains, fruits, and vegetables are all natural sources of carbohydrates. Carbohydrates provide energy to the body, particularly through glucose, a simple sugar that is a component of starch and an ingredient in many staple foods. Carbohydrates also have other important functions in humans, animals, and plants. Starch is bold, but I don't get why. I guess we'll write down starch. Just write down the word starch. But I already know what starch is, so I think I'll just write it down to make sure that I know it.
Go counting them.
Wow.
You've done 7 so far.
New drinking game. Drink every time Jose breathes into the mic. You know what? If I had a better mic,
8.
this wouldn't be happening. And I'll have one soon, I promise.
You have money to buy one. You still have to.
I'm a college student. I can't be spending money like that. I just spent like $80 today, so.
With what?
None of your business.
Or 2 sodas, a monster?
No, I had to buy some shit for school. Oh wow.
Fight me. Bite me.
Okay, so molecular structures. Carbohydrates can be represented into stoichiometric. I don't know. Let's see. How do we pronounce this word?
I got you. See, never seen me drink water
Okay, I
before.
thought I chose that. Wow, is Islet watching? What up, Islet? I don't know if she's watching. Okay, shut up music for a little bit. The fuck is my stop music button? I heard this.
Is Elizabeth your friend or?
Yeah. What? Stoichiometric.
Stoichiometric.
Stoichiometric. Okay.
Sounds like a U.
Stoichio. What the fuck?
Stoichio. Can I say?
Stoichiometric. No, she is watching me watch you. Ah, nice. That works too, you know.
Stoichiometric.
You should live stream yourself watching me, you know. Streamception. Stoichiometric. Okay, enough. Stoichiometric.
Stoichiometric.
Okay, where was it? By stoichiometric formula, CH2O, where N is CH2O N, where N is the number of carbons in the molecule. In other words, the ratio of carbon to hydrogen to oxygen is 1 to 1 in carbohydrate, 1 to 2 to 1 in carbohydrate molecules. This formula also explains the origin of the term carbohydrate. The components are carbon, carbo, and the components of water, hence hydrate. Carbohydrates are classified into 3 subtypes: monosaccharides, disaccharides, and polysaccharides.
You never get bored of this?
Of what?
This.
No, I like biology.
The hardest one. So you're getting used to the hard things.
Carbohydrates can be
There won't be so much fun
so
to us.
carbohydrates. Carbohydrates can be represented. Okay, let's see, represent it.
You've lost all your views. See you watching.
By the stoichiometric formula. Which is, again, parentheses, CH2O parentheses N.
Just very light.
N is the number of carbons in the molecule. Oh fuck. No, oh, fuck. Number of what? What is it? Of carbons.
The light. And hard whatever.
Molecule. I misspelled it. Wow. Good job, Jose. You're doing great.
Who spells molecule?
Me. Okay, so we'll highlight carbohydrates and we'll highlight the formula in orange.
I think just send us the only one watching you.
Oh well, that's fine with me. Like I said, I didn't even expect anybody to watch me in the first place, so I'm not tripping about nobody watching me. Even if nobody watches, it'll be uploaded afterwards.
People watching afterwards. Do you know that, Jose?
Cool,
That.
cool. Okay.
I think that you know that. I just said
Okay, so we're done with that. Okay, so carbohydrates, monosaccharides, disaccharides, polysaccharides. I already know that. It's gonna go into detail now, I guess, into the monosaccharides. Because the next one is monosaccharides. Okay, monosaccharides. Mono being one, saccharide sweet. Okay, so monosaccharides are simple sugars, the most common of which is glucose. In monosaccharides, the number of carbons usually ranges from 3 to 7. Usually, what? The number, okay, from 3 to 7, most monosaccharides. Names end with the suffix "-ose". If the sugar has an adenine group, the functional group with the structure are CHO, it is known as aldose. If it has a ketone, I don't know, KETONE group, the functional group with the structure RC parentheses equals OR. It is known as ketos. Ketos, depending on the number of carbons in the sugar. They may also be known as trioses. Trioses, 3 carbons. Pentoses, 5 carbons, or hexoses, 6 carbons. And then it has an illustration. Okay, I can't put any song on. I I can't. I tried. No, y'all can't hear it. Or were y'all able to hear it? I don't think y'all were. But I'm sorry. You'll have to play the song yourself. Just and hear me at the same time. That works too. I mean, and that way you get your own choice of song. Shit.
Must be nice.
And then okay, so we're gonna write some of the properties of monosaccharides though, to memorize them. Probably the most important ones. Monosaccharides. I won't get too specific. I'll do that in a lecture, like the more important things, because I know the teacher will mention them. So, simple sugars. Okay, so most common. I'll do it in bullet points. I think that's a good way to go about this. Is glucose, monosaccharides, usually ranges from 3 to 7. Okay, so number of carbons. Carbons, usually 3 to 7. Okay. Then most names end with O's. Yeah, that was my phone. That's why I turned like that. Yeah, into O's, right? Yeah. Okay. So next bullet point. It keeps this cartoon. The functional is it's going to see depending on the carbons of sugar. They may also be known as. Okay, I'm gonna write that down. I don't think it's that important. If it is, I'll just write it in a lecture again. Okay, so we'll highlight monosaccharides, and then we'll have we'll do. Okay, so we have graph, not graph, but like a depiction of I guess common monosaccharides. I don't know if I should draw it. I'll probably print it out instead later. But yeah. So monosaccharides. Okay, so that's a figure, carbon group, and number of carbons in each backbone. All those have a carbonyl group indicated as green at the end of the carbon chain of the cytosine. It's carbon in the middle of it. Yeah, I should actually like put put up the online version so y'all can actually see what the fuck I'm reading. Like let me try that. Let me try that. I don't know what my sister is doing, to be honest, but I guess I'll just let it happen. Let's see. This is chapter 3. And right now we're doing carbohydrates and lipids. Yeah, I'll leave this. Shut up, you know I'm good at drawing. Okay, prepare notes. Reading assignment. I've actually never opened this since I have the book, so I have no clue how those mean. Okay, I think this book is different. What the hell? Is it? Because this is not what my book looks like. Or no, it is, right? I have that picture of bread. Oh yeah, it is. Never mind. No, that's my sister. What the fuck? Wait, what are you talking about? The one that in my hair, or who, Sterling? Who are you talking about? Oh fuck, I went too far. Shout out to Islet, even though she ain't watching me, but I guess the food.
Isn't it the one we took to Tyler?
Yeah. Okay, so that's what I have. That's what I'm looking at right now. Monosaccharides. Okay, but I'll go and read. Okay, so the chemical formula for glucose is C6H12O6. In humans, glucose is a very important source of energy. During cellular respiration, energy is released from glucose, and that energy is used to help make adenosine triphosphate. Plants synthesize glucose using carbon dioxide and water, and glucose is in turn is used for energy requirements for the plant. Excess glucose is often stored as starch that is catabolized. The breakdown of larger molecules by cells, by humans, and other animals that feed on plants. Galactose, part of lactose or milk sugar, and fructose, found in sucrose in fruit, are other common monosaccharides. Although glucose, galactose, and fructose all have the same chemical formula, CH12O6, they differ structurally and chemically and are known as isomers because of the different arrangement of functional groups around the asymmetric carbon. All of these monosaccharides have more than one symmetric carbon. No, that's my sister. No, es que no me peiné hoy, so that's why it's all tangled. And I need trim. That's why it gets tangled as fuck too. Okay, so I'm right here. Yeah, I know. That's why I said I need trim. Glucose, galactose, and fructose are all hexoses. They're structural isomers, meaning they have the same chemical formula. Okay, so here we see them, same chemical formula, but they're arranged differently. Okay. Okay, I'll go to the next. Right there. Thank you. Glucose, galactose, and fructose are isometric monosaccharides. Hexoses, meaning they have the same chemical formula but have slightly different structures. Okay, so I'll write that down. I don't think it'll be that important, but okay, so glucose, galactose. No, but he couldn't see you. He just saw like your hands and shit. And fructose are isometric. Oh fuck. Isomeric. Okay. Monosaccharides, right? Yeah. Monosaccharides. Nah, man. I mean, if you want to learn it, well, do it, but it's up to you. I mean, you might subconsciously learn it. That's why I asked, should I read it out loud? And then I had the great response by just sending us saying, read it out loud, you pussy. And so I was like, okay, I'll read it out loud. Okay, so that means they have same formula, but different structures. Okay, so monosaccharides can exist in a linear chain or as ring-shaped molecules. In aqueous solutions, they are usually found in ring forms. Glucose is in a ring can have two different arrangements of the hydroxyl group around the anomeric carbon 1 that makes isomeric in the process of ring formation. If the hydroxyl group is below carbon number 1 in the sugar, it is said to be alpha A position. If it is above the plane, it is said to be beta B position. I sure won't remember that. So if they go over the lecture, then I'll write it down because I don't know if this is important or essential. I mean, it's all important, but you know. I mean, man, you still watch it, man. You'll learn it. You'll learn it for sure. I believe in you.
Does he have a scar on his face or just
So now we move on to disaccharides, which is two monosaccharides, right? That okay, so that's that they undergo a dehydration reaction, meaning that they go together and it requires energy. See, I'm learning shit now.
I'm gonna turn my head like you did and shave that
Oh, cool. So now we'll do disaccharides. Oh, I forgot to move this for you guys.
part. What a great streamer you are.
And they are again formed when two monosaccharides undergo dehydration.
Stop watching.
Undergo dehydration reaction. Okay. And we're ready to move on in just a second. We'll highlight disaccharides, just to make sure that we look at it when we're looking through our notes.
Let me just look like a monster.
Okay, so disaccharides. Okay, also known as condensation reaction or dehydration synthesis. During this process, the hydroxyl group of one monosaccharide combines with the hydrogen of another monosaccharide. So, the hydroxyl group. Oh, what the fuck? Okay, hydroxyl group combines with
Aren't you supposed to put it
the
away
hydrogen
after that?
of the other. Okay. And releasing a molecule of water and forming a covalent bond. Okay, so we'll just write down covalent bond. So releases water. We already knew that because it's dehydration. And it is, again, a covalent bond. I will highlight. Nah, that's good. Okay, forms between a carbohydrate molecule and another molecule. In this case, between two monosaccharides is known. Okay, so what? A covalent bond formed between a carbohydrate molecule and another molecule, in this case between two monosaccharides, is known as glycosidic bond. Te dije.
Estoy viendo el stream de José. Estoy viendo el stream de José.
Ya dale a dormir. No, well, yeah, I don't know. I didn't really like Miss Rose's class that much, to be honest. I didn't. But yeah. Covalent bond. Okay, so a covalent bond formed between a carbohydrate and another molecule. Okay, so we'll write it like this: carbohydrate molecule plus other molecule. And we'll write covalent bond above the plus sign. Equals like glycosidic bond. Glycosidic bond. It is bolded, and we're supposed to learn those words, so that's why.
I'm done.
True, you guys both are watching like stuff for science majors. Are you both good? It's both art majors, right? Yeah. I haven't been able to work on any animations lately, so That sucks. But hopefully I'll get to work on one soon. I'm chewing gum now. Does that add to the SMR? ASMR?
What's if it's too long?
Okay, so we did that. Acidic bond. And it can also be part of alpha beta type. So it probably will be important for later. And now we're going right here. Common disaccharides include lactose, maltose, and sucrose. Oh yeah, I was gonna do the bullet points. I totally forgot about that. Okay, I guess we'll start doing points now. So, okay, so we'll do common disaccharides. Ew, stop, those are disgusting. Okay, so they include lactose, maltose, and sucrose. Yeah, I just pressed into the mic again, so take a shot, guys. Okay, and now we move on to polysaccharides. Goodbye, Sterling. Have a great night. Sleepy sleep. Okay, so polysaccharides. And we highlighted because that's one of our main topics. Uh-oh, video output low. No. Let's hope the stream doesn't fall. Because apparently it's not going very well right now. Fuck. I think it's going down. I hope it's not. I took a shot of something else. Whatever you have. Milk? You have milk? No? Water? Take a shot of water. I forget the cam is on because I can't see it. Is it even still on? Can you even see me? Ew, you can see me. Oh, my hair looks so luscious because my little sister brushed it and shit. Oh my god, look at that shine. Jesus. Damn. Damn. Okay, enough. Same just said. That's funny. Mother lives a baby. Okay, so polysaccharides. Oh wow, just good. Okay, longer does not mean better. Okay, and your hair is insane. There's not even a comparison. Okay, that's not even fair. Okay, so polysaccharides, a long chain of monosaccharides linked by. No que ya te dijeron a dormir. Te van a cagar si te van a quedar. Oh, for real. Okay, so a long chain of monosaccharides linked by glycosidic bonds is known as a polysaccharide. So it's a long chain of monosaccharides linked by glycosidic bonds. And that's our first bullet point. No, that should be the definition. That's not a bullet point. So long chain of macromolecules. I mean monosaccharides. Fuck. It's kind of hard to see because of the glare. That's what I'm looking with this textbook. It's like glossy, so you can't see it very well at times. With under this light.
You could move the table.
No, even moving the table doesn't work. I've moved the bulbs. I've moved the table. I still see the glare. Okay. You can move up in the. Doesn't. No. Okay. Stop. So long chain of linked. Okay, so I'm done writing the definition for polysaccharides. The chain may be branched or unbranched. Okay, so we'll write that as a bullet point. Branched or unbranched. Mamutsaka. Wow. Yeah, those are my favorite too, starting. Those are great, you know? They're amazing. They're the basis of life. Branched or unbranched. What? Okay, so they're branched or unbranched. And it may contain different types of monosaccharides. The molecular weight may be 100,000 daltons or more depending on the number of monomers joined. So weight is 1,000 daltons or more. 100,000 daltons or more.
Can you ban anyone from the chat?
Yes, but I'm not going to.
No, just.
Yeah, you can. Okay. Or more depending on the number of monomers joined, starch, glycogen, cellulose, and chitin. It's CHITIN. Are primary examples of polysaccharides. So okay, so we'll do. Okay, so examples. EX dot are starch, glycogen, glycogen, not glycogen, and cellulose. And chitin. I don't know what chitin is. I guess he'll tell us in a bit, because, I did give us what our examples were in the previous ones. Okay, starch is the stored form of sugars in plants and is made of a mixture of amylose and amylopestin, both polymers of glucose. Plants are able to synthesize glucose, and the excess glucose beyond the plant's immediate energy needs is stored as starch in different plant parts, including roots and seeds. The starch in the seeds provides food for the embryo as it germinates and can also act as a source of food for humans and animals. The starch that is consumed by humans is broken down by enzymes such as salivary amylases into smaller molecules such as maltose and glucose. The cells can then absorb glucose. Okay, so we knew that starch is made up of glucose monomers that are joined by alpha 1 through 4 or alpha 1 through 6 glycosidic bonds. The number 1 through 4 and 1 through 6 refer to the carbon number of the two residues that have joined to form the bond. As illustrated in figure 3.9, amylose is starch formed by unbranched chains of glucose monomers, only alpha 1 through 4 linkages, whereas amylopectin. So it keeps on mentioning alpha, so that was important, but I'll learn it in class. If not, I'll come back tomorrow or some shit. There's a branch polysaccharide alpha 1 through 6 linkage at the branch points. Wow. She just read it before I did.
I'm up for it.
No. Anybody just tell me some more money. Everybody's got somebody. Everybody but me. Why can't anybody just tell me that I'm somebody's? Glycogen is a storage form of glucose in humans and other vertebrates that is made up of monomers of glucose. Glycogen is the animal equivalent of starch and is a highly branched molecule, usually stored in liver and muscle cells. Whenever blood glucose levels decrease, glycogen is broken down to release glucose in a process known as glycogenolysis. Cellulose is the most abundant natural biopolymer. The cell wall of plants is mostly made of cellulose. This provides structural support for the cell. Wood and paper are mostly cellulosic in nature. Cellulose is made up of glucose monomers that are linked by what was B? It wasn't alpha. It was fucking. Ugh, I don't remember. Does anybody remember? I just ripped the page. Oh well. I bought it, so it's fine. What did you do? This feels heavy on top of my head. I can't find it. I guess we'll just call it something else. Fuck it. Okay, let's go. Next page. I don't even know what it looks like because my sister did it. Wow. That's not too bad, I guess.
I would have done better if I could have seen you do it, but
Okay, I need to go to the restroom. I'll be back.
what am I supposed to do?
You talk to them. They're all crazy.
Okay. What am I with the what? There's only two of them. He'll probably take it off before he gets back. Oh crap. This doesn't fit me. It's too big. Hi. I know, but he would have gotten mad and told my dad, and I would have had to go to sleep. He's back. Well, he's coming back. Hi. Welcome back. Nothing. It just told me I should have stopped there, which I'm totally fine with, but I mean. Why doesn't it have a sting?
It does. It's hidden. It's not like they don't have it out. They like bring it out when they need to. Okay.
That's not what you're showing me.
Well, I don't know.
You said they always have it on.
I thought it was a movie. Okay, as shown in figure 3.10, every other glucose monomer in cellulose is flipped over, and the monomers applied to the cell chains. This gives cellulose its rigidity and high tensile strength, which is so important to plant cells. While the B1 through 4 linkage cannot be broken down by human digestive enzymes, herbivores such as cows, koalas, buffaloes, and horses are able, with the help of specialized flora in their stomach, to digest the plant material that is rich in cellulose and use it as food source in these animals. Certain species of bacteria and protists reside in the resumen, parts of the digestive bacteria that digest cellulose, giving it an important role in the digestive system of ruminants. Celluloses can break down cellulose into glucose monomers that can be used as energy sourced by the animal. Termites are also able to break down cellulose because of the presence of the organisms in their bodies that secrete cellulase. Oh, thank you for the compliments on my hairstyle. Props to my sister for doing it. I had nothing to do with it, honestly. Okay. Carbohydrates have various functions in different animals. Arthropods, insects, crustaceans, and others have an outer skeleton called the exoskeleton, which protects their internal body part, as seen in the bee in figure 3.11. This exoskeleton is made of the biological macromolecule chitin. This is what I was talking about. Also, it has to do with the exoskeleton in insects and you know all of that. So chitin, which is a polysaccharide containing nitrogen, it is made of repairing units of N-acetyl glucosamine, a modified sugar. Chitin is also a major component of fungal cell walls. Fungi are neither. What are you doing?
It's what the guy said it was missing.
Are neither animals nor plants and form a kingdom of their own in the domain in the what? I'm so lost. You made me lose. Okay, so I'll just a modified sugar chitin is also a major component of fungal cell walls. Fungi are neither animals nor plants and form a kingdom of their own in the domain Eukarya. Okay. So benefits of carbohydrates. Are carbohydrates good for you? People who wish to lose weight are often told that carbohydrates are bad for them and should be avoided. Some diets completely forbid carbohydrate consumption, claiming that a low carbohydrate diet helps people to lose weight faster. However, carbohydrates have been an important part of human diet for thousands of years. Artifacts from ancient civilizations show how the presence of wheat, rice, and corn in our ancestors' storage areas. Carbohydrates should be supplemented with proteins, vitamins, and fats to be parts of a well-balanced diet. Calorie-wise, a gram of carbohydrates provides 4.3 calories. Kilocalories? I think. Yeah, kilocalories. For comparison, fats provide 9 kilocalories over grams, a less desirable ratio. Carbohydrates contain soluble and insoluble elements. Oh yeah, thanks, Atara. And insoluble elements. The absolute part is known as fiber, which is mostly cellulose. Fiber has many uses. It promotes regular bowel movement by adding bulk, and it regulates the rate of consumption of blood glucose. Fiber also helps to remove excess cholesterol from the body. Fiber binds to the cholesterol in the small intestine, then attaches to the cholesterol and prevents the cholesterol particles from entering the bloodstream, and then cholesterol exits the body via the feces. Fiber-rich diets also have a protein role in reducing the occurrence of colon cancer. In addition, a meal containing whole grains and vegetables gives a feeling of fullness. As an immediate source of energy, glucose is broken down during the process of cellular respiration, which produces ATP. The energy currency of the cell. Without the consumption of carbohydrates, the availability of instant energy would be reduced. Eliminating carbohydrates from the diet is not the best way to lose weight. A low-calorie diet that is rich in whole grains, fruits, vegetables, and lean meat, together with plenty of exercise and plenty of water, is a more sensitive way to lose weight. So now you know how to lose weight, guys.
You're welcome. Not missing anymore.
Okay, 3.3 lipids. So this is the last section that we have to do today. It's been oh yeah, next. Yeah, so we're still good. Hopefully I'll get done by 12. I'll get done with this pretty soon, but I still have to do other shit that has to do with biology as well. This is like the main thing, like, going through it.
Did you still talk if there was no one watching?
There's 3 people watching.
I said, would you still?
Yeah, because I'll upload later. I mean, not that anybody's gonna watch it when it uploads later, but still. Okay, 3.3. Lipids. Lipids include a diverse group of compounds that are largely non-polar in nature. This is because They are hydrocarbons that include mostly nonpolar carbon-carbon or carbon-hydrogen bonds. Nonpolar molecules are hydrophobic, meaning water-fearing or insoluble in water. Lipids perform many different functions in a cell. Cell storage, energy for long-term use, used in the form of fats. Lipids also provide insulation from the environment, from plants and animals. For example, they help keep aquatic birds and mammals dry when performing a protective layer over fur or feathers because their water-repellent hydrophobic nature. Lipids are also the building blocks of many hormones that are important constituent of all cellular membranes. Lipids include fats, oils, waxes, phospholipids, and steroids. AIDS candy? What the fuck? What is that?
Pills don't make you skinnier, they make you sicker. If you ever complete some kind of SMR, it's
I know. ASMR. I'm doing ASMR now, guys. And I accidentally licked the fucking microphone. God damn it. God damn it, guys. And, yeah, so now we're gonna go through, what the fuck? Oh, yeah, fats and oils. Okay, first we're gonna write about lipids. No, not yet. No, we're gonna still write about lipids. We're gonna write what lipids are, and we're gonna highlight it in yellow. Okay, enough of that. Anyway, lipids.
look it up, it's a real candy.
And see, no, see, no, I don't care. Looking for some of want to you. No. What the fuck, highlighter? You saw that?
Yes.
My highlighter squirted all over. How would you know that? I'll look it up later.
Help you with your lipids. What?
Are you telling me fat, Sterling? Cause you ain't wrong.
But you're fat too. To some extent.
Diverse group of compounds. Okay, so we're right. Diverse
And I'm part of it.
group of compounds. And largely nonpolar. Largely nonpolar in nature. Okay, we'll just write that. Lipids going to for Okay, so that's fats and oils. A fat molecule consists of two main components, glycerol and fatty acids. Glycerol is an organic compound alcohol with 3 carbons, 5 hydrogens, and 3 hydroxyl groups. Fatty acids have a long chain of hydrocarbons to which a carboxyl group is attached, hence the name fatty acid. The number of carbons in the fatty acid may range from 4 to 36. Most common are those containing 12 to 18 carbons. In a fat molecule, the fatty acids are attached to each of the 3 carbons of the glycerol molecule with an ester bound to an oxygen atom. Wow, just say yeah, but you're right though. I am. I is.
Part of being fat.
Oh yeah, I never scrolled down, but anyway. That's our glycerol, our fatty acids, and our
I'm fatty.
triacylglycerol, which is that one. Which is, wow, super long molecule. Oh, I thought this was like a fucking pimple or some shit. I forgot I had stickers on my forehead. Like, what the fuck is this? Is this a piece of skin hanging? I'm gonna like take it off, but no, it's a sticker.
It's what was missing.
During this ester bound formation, three water molecules are released, the three fatty acids and the triglycerol may be similar or dissimilar. Fats are also called triglycerols or triglycerides because of their chemical structures, and fatty acids have common names that specify their origin. For example, palmitic acid, a saturated fatty acid, is derived from the palm tree. Arachidonic acid is derived from Arachis hypogra, the scientific name for groundnuts or peanuts. Fatty acids may be saturated or unsaturated in a fatty acid chain if there are only single bonds between neighboring carbons in the hydrocarbon chain. The fatty acid is said to be saturated. Saturated fatty acids are saturated with hydrogen. In other words, the number of hydrogen atoms attached to the carbon skeleton is maximized. Stearic acid is an example of a saturated fatty acid. When the when the when the hydrocarbon chain contains a double bond, the fatty acid is said to be unsaturated. Acrylic acid is an example of an unsaturated fatty acid.
I have a lot of fatty acid.
This is still so much. No, it's not. Most unsaturated fats are liquid at room temperature and are called oils. If there is one double bond in the molecule, then it is known as a monosaturated fat. Example, olive oil. If there is more than one double bond, then it's known as a polyunsaturated fat. Example, canola oil. What are you doing? What'd you do that for?
Fixing it.
Fixing what? You can still see me. I don't even think they can see what these stickers are.
It's the bikini the guy showed a little bit earlier.
Look, Sterling, it's what you wanted. You see that? You see that, Sterling? I hope you're happy now. Cause there it is.
You got what you want. So the fatty acid is unsaturated?
No, it's
Saturated.
well, it depends. It can be either of or. Like if the hydrocarbon chain contains a double bond, it's unsaturated, and saturated are saturated with hydrogen, so the number of hydrogen atoms attached to the carbon skeleton is maximized. Yeah, I could see, Sterling. See, good job. You said you wouldn't learn anything, but here you are learning stuff. Okay, when a fatty acid has no double bonds, it is known as a saturated fatty acid because no more hydrogen may be added to the carbon atoms of the chain. A fat may contain similar or different fatty acids attached to glycerol. Long, straight fatty acids with single bonds tend to get packaged tightly and are solid at room temperature. Animal fats with stearic acid and palmitic acid and the fat with butyric acid are examples of saturated fats. Mammals store fats in specialized cells called adipocytes.
Cool story. What story?
When globules of fat occupy most of the cell's volume in plants, fat or oil is stored in many seeds and is used as a source of energy during seeding development. Unsaturated fats or oils are usually of plant origin and contain cis unsaturated fatty acids. Cis, just like me. A cis male.
But can the fatty acid be unbonded? I mean, if you go skinny.
Yeah, it can be unbonded because you break it down. If your body needs it, it can break it down. So yeah, it can be unbonded. You can break the bond with the polymers.
Let's start being friends though.
What are you talking about, Atara? Okay, so cis and Cis and trans indicate the configuration of the molecule around the double bond. Oh, we're learning about cis and trans here too. If hydrogens are present in the same place, it is referred to as a cis fat. If the hydrogen atoms are on two different planes, it is referred as a trans fat. The cis double bond causes a bend or a kink. Oh, a kink. Ooh. That prevents the fatty acids from packing tightly, keeping the liquid at room temperature. Olive oil, corn oil, canola oil, and cod liver oil are examples of unsaturated fats. Unsaturated fats help to lower blood cholesterol levels, whereas saturated fats contribute to plaque formation and diabetes. Okay, this is too heavy to study too. Bouch and thou. I don't feel like listening to that. Tampoco. Iron Man, no. Ooh. Nah, not for right now. I'll leave some rat bone on. Was that like a thing in an episode? The adipose? You watch Doctor Who? Well, how do you know? What the hell? Oh, you're talking about that? I think. What the fuck? Study the kink some more. Oh, that's all it tells us about the kink. So kink.
Kinky.
You're feeling like you won't play right. I used to know, but now that
There's a
shit
lot about
don't
fatty
feel
acid.
right.
Omega fatty acids.
It's funny that you put it in between parentheses because actually this was parentheses in here. The song so loud. I don't know what to write up on this one. Like, all I have down for lipids is what a lipid is. I guess I'll really pay attention when they talk about lipids in class.
It will make this drink.
Trans fat. In the food industry, oils are artificially hydrogenated to make them semi-solid and a consistency desirable for many produces processed food products. Simply speaking, hydrogen gas is bubbled through oils to solidify them. During this hydration process, double bonds of cis conformation in the hydrocarbon chain may be converted to double bonds in a trans conformation. Margarine, some types of peanut butter, and shortening are examples of artificial hydrogenated trans fats. Recent studies have shown that an increase in trans fats in the human diet may lead to an increase in levels of low-density lipoproteins, LDL, or bad cholesterol, which in turn may lead to plaque deposition in the arteries, resulting in heart disease. Many fast food restaurants have recently banned the use of trans fats, and food labels are required to display the trans fat content.
Can molecules keep together? Just wondering. What was the question?
I know.
Are you gonna answer it?
Never ends. No, they can't, because that means they pack more tightly. So, they really can't because they are unsaturated, so they can have another carbon molecule join them, if that's what you're looking for.
Not
But-
used as being.
But it is solid, so you would have to heat it. It would have to be heated up in order for that to happen.
So you're just wondering.
Or at least that's what I'm thinking.
Yeah, that's what you are.
Okay, omega fatty.
Omega fatty acids.
Yeah.
Good fatty acids.
Essential fatty acids are fatty acids required but not synthesized by the human body. Consequently, they have to be supplemented through indigestion via the diet. Omega-3 fatty acids, like shown in figure 3.17, fall into this category and are one of the only two known for humans. The other being omega-6 fatty acid. They are polyunsaturated fatty acids and are called omega-3 because the third carbon of the end of the hydrocarbon chain is connected to its neighboring carbon by a double bond. The adipose were literally human fat. They gave people pills that would help them lose weight, but it just killed them and turned them into adipose, basically walking fat. really like Doctor Who episode. Huh. Is that like from the new Doctor Who? Or the old Doctor Who? A phosphate
What's
group
the new
alone
Doctor?
attached a di- di- diaglycerol does not qualify it as a phosphate. What? What? Oh my god, okay, I skipped the whole fucking section. Okay, the farthest carbon away from the carboxyl group is numbered as the omega carbon, and if the double bond is between the third and fourth carbon at the end, it is known as the omega-3 fatty acid. Nutritionally important because the body does not make them. Omega-3 fatty acids include alpha
Until you sleep in 25 minutes.
sleep, alpha lysinic acid, ico eicosapentaenoic acid, and docosahexaenic acid, all of which are polysaturated. Salmon, trout, and tuna are good sources of omega-3 fatty acids. Research indicates that omega-3 fatty acids reduce the risk of sudden death from heart attacks, reduce triglycerides in the blood, lower blood pressure, and prevent thrombosis by inhibiting blood clotting. They also reduce inflammation and may help reduce the risk of some cancers in animals. Like carbohydrates, fats have received a lot of bad publicity. It is true that eating an excess of fried foods and other fatty foods leads to weight gain. However, fats do have important functions. Many vitamins are fat soluble, and fats serve as long-term storage form of fatty acids, a source of energy. They also provide insulation for the body, therefore healthy fats in moderate amounts should be consumed on a regular basis. Waxes. Wax covers the feathers of some aquatic birds and leaf surfaces on some plants because of the hydrophobic nature of waxes. They prevent water from sticking on the surface. Waxes are made up of long fatty acid chains stratified to long chain alcohols. Phospholipids. Phospholipids are major constituents of the plasma membrane, the outermost layer of animal cells. Like fats, they are composed of fatty acids chains attached to glycerol or sphingosine backbone instead of three fatty acids attached as in triglycerides. However, there are two fatty acids forming diacylglycerol, and the third carbon of the glycerol backbone is occupied by modified phosphate group.
The fedora fell.
Oh, you literally gave me a fedora? Wow. 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 You were the fedora.
I'm cute. No, I'm not really. I'm just prisoner of mine. I'm the ugliest person in the world. We won't have one. Do we have one? No, right?
No, we don't have any scarves. Okay, almost done. I'm gonna speed through this. A phosphate group alone attached to the glycerol does not qualify as a phospholiquid. I don't even know where we're at. It is phospholipid, the precursor of phospholipids. The phosphate group is modified by alcohol phosphatidycloline and phosphatidylserine are two important phospholipids that are found in plasma membranes.
Yeah, that's why I look ugly in the fedora. I'm the ugliest person on earth, remember?
Final word of the fedora. A phospholiquid in a molecule with two fatty acids and a modified phosphate group attached to a glycerol backbone. The phosphate may be modified by the addition or charged or polar chemical bonds. Two chemical groups that may modify the phosphate, chlorine and serine, are shown here. Both chlorine and serine attached to the phosphate group at the position labeled R via the hydroxyl group indicated in green. I didn't even have to read that. Fuck. A phospholipid is an infinitic molecule, meaning it has a hydrophobic and hydrophilic part. Oh, that's interesting. The fatty acid chains are hydrophobic and cannot interact with water, whereas the phosphate-containing group is hydrophilic and interacts with water. I can't speak with an English accent. I suck at accents, honestly. I can't do them. I can't even think of it right now, like the accent. Like, to be honest, I really can't.
Hello. Someone has a girlfriend.
Okay, okay. Let's get back to this.
Necesito's taken.
Um. Okay, so the head of the hydrophilic part and the tail contains the hydrophobic fatty acids in a membrane. A bilayer of phospholipids forms the matrix of the structure. The fatty acid tails. Okay. All phospholipids face inside away from the water, whereas the phosphate groups faces the inside aqueous side. Phospholipids are responsible for the dynamic nature of the plasma membrane. If a drop of phospholipids is placed in water, it spontaneously forms a structure known as a micelle, missile, where the hydrophilic phosphate head faces the outside and fatty acids face the interior of the structure. Steroids. Unlike the phospholipids and fats discussed earlier, steroids have a fused ring structure. Although they do not resemble the other lipids, they are grouped with them because they are also hydrophobic and insoluble in water. All steroids have four-linked carbon rings, and several of them, like cholesterol, have a short tail. Many steroids also have a hydro. What is it? Hydrofluoric acid, I think. I have it somewhere here.
I'm going to sleep in 20 minutes.
What is it? What is it? What is it? Come on, come on. I have it here somewhere. Hydroxide. That's what it is. Hydroxide. Have the hydroxide functional group, which puts them in the alcohol classification. Sterols. Cholesterol is the most common steroid, so cholesterol is a steroid. Cholesterol is mainly synthesized in the liver, yeah, okay, and is a precursor to many steroid hormones such as testosterone and estradiol, which are secreted by the gonads and endocrine glands. It is also the precursor of vitamin D. Cholesterol is also the precursor of bile salts, which help in the emulsification of fats and their subsequent absorption by cells. Although cholesterol is often spoken of in negative terms by lay people, it is necessary for proper function of the body. It is a component of the plasma membrane of animal cells, and it is found within the phospholipid bilayer. Being the outermost structure in animal cells, the plasma membrane is responsible for the transport of materials and cellular recognition, and it is involved in cell-to-cell communication. And that's it, guys. That's chapter 3.1 through 3.3. So that's all I have to read, but I still have more to do. Jesus Christ. That's why biology is so ugh. I agree, sir. Oh my god, ew, I'm wearing a fedora.
Looks nice on you.
Not even. Okay. Let's see what else we have to do. So we're done with section A1. I guess we're done with 2. Watch one of the 2 carbohydrates videos and take notes. So now I have to watch videos. Let me see if I can set that up for you guys so you can watch the videos también.
No, I mean, okay. He's my brother. I can't say that.
What the fuck is it? What am I doing? I like fucking transported to another dimension in my brain there. I was fucking somewhere else. We're on a Battery Park.
I like your highlighters.
There's something dark hanging over my head. I'm 17, don't hold your breath.
Do you have to write with
There's
pen?
something dark hanging over my head. No, I can write with whatever I want.
But please, I know your pen.
Okay, let's pause this since I have to watch videos now.
Can we still see you here?
Yeah, I can still see you. Okay, so carbohydrates presentation video is what we have to watch, right? Yeah, and then we'll have to watch lipids.
Upper muscle. How do you know?
Liz, can y'all hear that? Is that? No. Y'all can't hear that, right? Wow, Sterling. Wow. Wow. Can't. How do I make you hear this? Can I? Let's see, window capture. Okay. Dashboard. YouTube.
Yeah, she said you can't hear it.
Yes, this one. Inner window, entire window.
Going to sleep in
You mean 4 minutes?
14 minutes.
Nah,
50 it goes to the end of the day.
oh, look here. Well, I don't know what happened, guys. To be honest, I don't know what I'm doing. Monitor capture, video capture, window capture. I don't know how you do this. Fuck, it's because I would have to stop streaming for that. I think. Yeah, because y'all can't hear it. Y'all can't hear it for some reason. Hold up. I think I might know what's going on. Well, hold up. If I do this, maybe.
Multiple subunits called.
Yeah, now you can hear it. No, I could actually hear it from here, so we'll be fine, and that way we can both hear it. Cause last time I changed the settings so you could hear what's through headphones, which is weird, but yeah. Okay, this is gonna be way loud, so let's turn it down a shit ton.
Called monomers. So if we put a whole bunch of one type of monomer together, we get a polymer. But how do we put them together? Biological polymers are created by a process called a condensation reaction. This process can also be called dehydration.
I think you're able to hear it now, right?
It creates chemical bonds.
You're able to hear me more?
Now, the reaction in reverse can break. The process is called hydrolysis.
Fuck it, I'll just leave it like that.
The names may not make much sense right now.
Okay, I don't even know what. Okay, let's just go back.
How can organisms synthesize complex molecules like proteins, carbohydrates, lipids, and nucleic acids? These biological molecules are usually known as polymers.
Yeah, I turned it down now. It should be good.
And a polymer consists of multiple subunits called monomers. So if we put a whole bunch of one type of monomer together, we get a polymer. But how do we put them together? Biological polymers are created by a process called a condensation reaction. This process can also be called dehydration synthesis and creates chemical bonds between the monomers. Now, the reaction in reverse can break those chemical bonds, and this process is called hydrolysis.
Okay, we
The
got
names
that
may
down.
not make much sense right now, but let's see how these processes actually work. To join two biological monomers, a hydrogen and hydroxyl group are removed, and water is formed. The shortened ends of the monomers connect in a covalent bond. Condensation is a term that basically means formation of a liquid. Since a condensation reaction results in the formation of a bond due to the removal of two hydrogens and an oxygen, this is an appropriate term. Hydrolysis is just the opposite. If a polymer needs to be split up, water can be added to break the covalent bonds between the monomers. Hydrolysis literally means water splitting. Sugar is a general term to use for carbohydrates, but be aware all sugars are not sweet. This is a picture from a microscope image, called a micrograph, from a cross-section of a plant root. Two carbohydrates are stained, cellulose and starch. Cellulose is stained green and is found in the cell walls of the plant cells. Starch is stained purple and is found within the cells. Both cellulose and starch are complex carbohydrates, and we'll learn more about them later on. All carbohydrates have a very similar structure. In most carbohydrate molecules, you will find two hydrogens for every carbon and oxygen atom. The N subscript means that we can have different multiples of this arrangement. For example, if we input a 5 for N, we will get a molecule with 5 carbon, 10 hydrogen, and 5 oxygen atoms. As in most organic molecules, the backbone is composed of carbon atoms. Attached to the carbon skeleton are hydroxyl groups that allow most carbohydrates to readily dissolve in water. This is how each monomer, specifically called a monosaccharide, of a carbohydrate is composed. Carbohydrates may consist of one or many monosaccharides bound together. Carbohydrates serve many functions in living organisms. Structural carbohydrates like cellulose and chitin provide strength and stability. When carbohydrates are bound to proteins, they form glycoproteins, which serve as identification markers on cells. And carbohydrates such as starch and even glucose store energy that can later be used by the organism.
Okay.
We will discuss some of these functions in more detail later on.
I'm so confused, I'm not paying attention. Fuck. Does anybody know the answer to this, guys? Oh my god, I wasn't paying attention. Anybody know? Anybody? Anybody? Come on. I know somebody knows. Somebody was paying attention, right? One of y'all? One of y'all was paying? No? No? I'm waiting. I'm not gonna answer until I see an answer in the comments. Because I know y'all know this. Y'all just don't want to answer because y'all been some hoes. Y'all been some hoes. Some hoes. Still don't see an answer. Still waiting. I'm still waiting. No? No? Nobody? Okay, fuck. Glycoproteins are used for cell recognition. I'm gonna go with all the answers are correct. Incorrect. Wow. Thank you.
In addition to hydroxyl, we also find
I love how it
orbital
doesn't tell you what
groups
which
in
one was the
sugars.
right one.
If the oxygen is double bonded to a carbon at the end of the skeleton, we call this specific type of carbonyl an aldose. But if the carbonyl occurs in the middle of the skeleton, the carbonyl is referred to as a ketose. Most monosaccharides, the monomers of carbohydrates, have 3, 5, or 6 carbons. If the monosaccharide has 3 carbons, it is called a triose. Glyceraldehyde is a triose that is produced during
Good night. Have a great night. You're leaving again because you said you were already gonna leave, but you didn't. And I'm glad you enjoyed the stream. Good night. Let's go.
photosynthesis. This monosaccharide is used to synthesize more complex monosaccharides. A 5-carbon sugar is called a pentose. Deoxyribose is a pentose found in DNA. A 6-carbon sugar is called a hexose. And while glucose is the monosaccharide used by most living organisms, organisms utilize many different hexoses for various reasons. Now, as you learned at the beginning, carbohydrates are composed of a ratio of carbon, oxygen, and hydrogen atoms. So if hexoses have 6 carbons, how many hydrogen and oxygen atoms would they have? Yes, 12 hydrogen, and 6 oxygen. But
Okay.
even though most hexoses have this molecular formula, the atoms are arranged in different ways. Molecules that have the same molecular formula but different structures are called isomers. For example, glucose has the molecular formula of C6H12O6 with a hydroxyl group attached to the 4th carbon in the same position as the hydroxyl on the 2nd carbon, while galactose has the same exact molecular formula, C6H12O6, but the hydroxyl group is in a different position. This may not seem like a big difference, but the position of the hydroxyls give glucose and galactose slightly different properties. And these bonds found in carbohydrates are very important. Carbohydrates sustain life as they are the products of photosynthesis, storing solar energy in the form of chemical bonds. They are ideal for storing usable energy due to the high percentage of shared electrons in the
Okay.
molecule.
I've been so quiet
All
because
those
I'm like,
carbon and hydrogen atoms bonded together have
I'm
similar
really trying to get this shit,
electronegativity.
man.
Therefore, the electrons are
I'll
not
get it
bound
in
as
lecture.
tightly
That's
to
what I
the
really
atoms.
like.
When the
You
bonds
know,
are broken, there is more free energy to power endergonic reactions.
get this shit.
But
Cause we
we
go
did
over all
mention
of it.
that glucose is the most important monosaccharide in organisms, so let's look at it in a little more detail.
Okay.
In aqueous solutions,
We're only halfway
such
through
as
the
the
video.
solutions found inside cells and the extracellular fluid, glucose does not typically exist in a linear state.
Okay.
As you can see, the carbons are numbered, from the terminal carbon on one end of the linear molecule, carbon 1, to the last carbon in the backbone, carbon 6. And in aqueous solutions, the hydroxyl attached to the 5th carbon and the carbonyl interact
Okay.
to form a ring structure. The formation of the new bond displaces the hydrogen of the hydroxyl. In addition, a hydrogen atom forms a bond with the oxygen of the carbonyl, converting it into a hydroxyl functional group.
They
We
just got
also need to
distracted and a
consider
bunch
the
of shit
position of that
happened.
hydroxyl
I have
group
no clue
on
what's
the
going
first
on.
carbon. The ring can form with the hydroxyl group in this position, and we would call the molecule alpha glucose. Or in this position, and we would call it beta
It
glucose.
was beta.
What would we
The
call
fucking
these
symbol
two
I can't
different forms of
remember.
glucose? Yes, isomers, because they have the
Isomers.
same molecular formula, but different structural
Different
formulas.
yes, isomers. Isomers. I forgot. What is a monosaccharide with 6 carbons called? That's hexose, right? Monosaccharides can vary in all the following ways except positions of hydroxyls where the carbon group is located, number of carbons, the presence or absence of a carbonyl group, number of carbons, right? Yeah. No, that's wrong. Position of hydroxyls, linear versus ring structure. No, because it can be in either position of hydroxyls. What are the fucking hydroxyls? Carbonyl group. Fuck it, I'm gonna go with that, even though I know it's wrong. Yeah. But I hate that it doesn't give you the
If
fucking right answer. That's fucking
monosaccharides are the
stupid.
monomers of carbohydrates, how are they added together to form polymers? By a condensation
I always get those
reaction,
questions
of
wrong,
course.
by the way.
In
I always get the
carbohydrates,
fucking video
covalent
questions
bond
wrong
that forms
every
between the
single fucking time.
monosaccharides is called a glycosidic linkage. Let's look at what we can form when two monosaccharides are joined. Disaccharides are carbohydrates composed of two monosaccharides joined by a glycosidic linkage. Some common disaccharides include sucrose, common table sugar, composed of the monosaccharides glucose and fructose, lactose, the sugar found in milk, composed of glucose and galactose, and maltose, a sugar derived from barley for fermentation to produce drinking alcohol, composed of two glucose molecules.
I'm not getting
So, here's
shit,
two
man.
glucose
What the
monomers.
fuck?
As you can see, they are both alpha glucose since the hydroxyls on the first carbons are in the down position. In addition, the sixth carbon is in the up position. To form a glycosidic linkage, a condensation reaction must occur. And, of course, It is the removal of a water molecule that forms the linkage. In this case, we have formed a very specific linkage. Since the two glucose molecules were the alpha forms, we call the covalent bond that has formed between the monomers an alpha 1,4 glycosidic linkage. The 1 and 4 refer to the
I have
fact
to
that
watch
the bond
two,
occurs
so one
between the
after
first
this one,
carbon
and that's
of
all.
one monosaccharide and the fourth carbon
So just
of
one
the
more
other
after this
monosaccharide.
one.
The resulting disaccharide is maltose. And if you will notice, the sixth carbons of the monomers are still in the up position after the bond is formed. Now let's take two different monosaccharides,
God.
galactose and glucose. This glucose is
These
different,
videos always
as
bore
it
me
is
to
the beta
fucking
form,
death,
with the
man.
hydroxyl on the first carbon in the up position. Take a close look at the beta-galactose. How does it differ from the beta-glucose? Right, they have the same molecular formula, but the hydroxyls on the fourth carbon are in different positions, and that makes
Oh my
them
God, I want to die.
isomers. Right. And when the condensation reaction occurs, a beta 1,4 glycosidic linkage is formed, giving us the disaccharide lactose. If you will notice, the sixth carbons do not remain in the same positions after the linkage forms.
Obviously
The glucose
not.
molecule must flip upside down,
Yeah.
so that the
To
six
form the bond.
carbons are in the opposite positions in this disaccharide. Now, do we have to stop at 2 monosaccharides?
Oh no.
No. In fact, very long chains of
Yup,
monosaccharides can form to produce
polysaccharides.
polysaccharides.
Woo, we're going
These
to
chains may have
polysaccharides,
hundreds
guys.
or thousands of
I hate
monomers.
these videos so much.
Common
these videos.
polysaccharides
I hate
include
these
starch,
videos.
glycogen, cellulose, chitin, and
Oh, it's pronounced
peptidoglycan.
chitin.
Let's
That
look
sounds
at
pronounced
each of these in more detail.
Peptidoglycan. Gliding cellulose.
Starch is the polysaccharide plants form in order to store their glucose for
Glucose.
later use.
Later use.
The potato plant stores its excess starch in the potato.
Potato.
If we look
Potato,
at
potato.
cells in a potato, we see the small structures amyloplast that contain the starch. And if we look at the
I just ate
starch,
potatoes
we can see
today.
it is composed of two forms,
For real.
helical amylose and branched amylopectin. The glucose monomers in amylose are joined by only alpha 1,4 glycosidic linkages, while the amylopectin has alpha 1,6 glycosidic linkages at the branch points. Glycogen is the polysaccharide animals form in order to store their glucose
Oh
for
my
later use.
God.
Glycogen is commonly stored in the muscles
The
and
muscles and liver. I was gonna say the
liver,
liver.
specifically in granules throughout the cell.
Okay.
Glycogen consists of glucose joined by alpha 1,4 glycosidic linkages. Its branch structure is similar to amylopectin, but glycogen does contain more alpha 1,6 linkages. Cellulose is the polysaccharide plants form for structural purposes. If we look at a plant, its cells are surrounded by a
Looking
tough
at it?
cell wall. A major component of cell walls
We already
is
saw
cellulose,
this.
which consists of glucose. While cellulose is a great structural material in plants, organisms who do eat large amounts of plant material, but cellulose is also a main part of the indigestible polysaccharides considered to be fiber, which keeps the digestive tracts of humans functioning normally. Chitin is the polysaccharide fungi and other organisms such as insects.
Exoskeleton.
Chitin is not composed of glucose molecules. Instead, the monosaccharide found in chitin is called N-acetylglucosamine, represented by the blue molecules in the above diagram. It is similar to glucose, but one of the functional
Shit,
groups
I don't want to
contains
go to school
nitrogen.
tomorrow either. You should sleep already because you go.
The
You go in
monomers are
way
joined by
earlier than I do.
beta-1,4 glycosidic linkages. Hydrogen
I don't
bonds
go
form
until
between the
9:30.
monomers of the chains, increasing the
going,
durability and
what time do you
strength
go in?
of this
8?
polysaccharide. Peptidoglycan is the polysaccharide bacteria used for structural purposes. Like chitin, peptidoglycan is composed of N-acetylglucosamine monomers. But it also contains another type of monosaccharide. These are joined by beta-1,4 glycosidic linkages,
What time do you go
and
in?
the peptidoglycan chains are linked together by short strands of amino acids.
Humans can digest starch but not cellulose because starch is alpha, cellulose is beta, cellulose is a branch molecule, cellulose is branched. Starch is branched molecule, cellulose is unbranched. Starch is a shorter molecule, starch is beta. I'm gonna go with this one. It's wrong. I knew it. Fuck me. Oh my god. Structural component in plants. Cellulose. Storage of energy in animals. It's glycogen. Structural component in animals. What? Storage of energy. Oh no, structural component. I'm so fucking lost. What the fuck? Structural component in bacteria. I'm gonna go with D. Storage of energy in plants. That's cellulose. Structural. No, storage of energy is starch. Yeah. And then structural component is cellulose. Then storage of energy in animals. Structural components, I think is I forgot how to pronounce it already. I'm gonna go with that. No, I just clicked clear. Oh my god. Fuck me, dude. Glycogen, C. Structural component in animals, I'm gonna go with B. Storage of energy is starch. And then structural component in bacteria, I believe is D, because I don't even know. Hey, I was right. That's the end of this video. Now I have to see the lipids. Let's see how long it is. I'll just open the YouTube version for that. Oh, this one's short, hell yeah. 3 minutes. Okay, now I'll open the flash version. Just because it's interactive and shit.
Unlike the other biomolecules, all lipids are not composed of the same monomers. However, they do share some properties. All lipids have carbon skeletons, like other biomolecules.
I'm
In
polar.
addition, they do not readily dissolve in water, as they are non-polar. Examples of lipids include fats,
Steroids,
and
phospholipids.
phospholipids. Let's look at fats first. Fats are used by organisms for long-term energy storage. They are composed of 3 fatty acids attached to a glycerol molecule. Therefore, they can also be called triglycerides. The fatty acids are composed of long hydrocarbon chains. Depending on the structure of the fatty acids, fats can be saturated or unsaturated. As you can see, the fatty acids are added to the glycerol by a condensation or dehydration reaction. 3 fatty acid tails are added to the glycerol, so 3 water molecules are removed to form these bonds. And while the bonds created are covalent bonds, as in any condensation reaction, these are specifically called ester linkages. The picture on the right shows a more realistic representation of a fat molecule's overall shape. If you notice, the 3 fatty acids are straight for this B-fat molecule. The fatty acids found in fats like butter and animal fat are straight. This means that there are no double bonds between the carbon atoms. Fats that have these types of fatty acids are called saturated fats and are typically solid at room temperature, as the fat molecules can pack closer together. However, if the fatty acids have at least one double bond between the carbon atoms, this causes a kink in the fatty acid tail. Fats that have these types of fatty acids are called unsaturated fats and are typically liquid at room temperature because the molecules cannot pack closely together.
Okay.
Our next lipid group is steroids. They are very distinctive, as they consist of 4 fused carbon rings. Steroids usually act as hormones in living organisms and include cholesterol, estrogen, and testosterone. Here are the molecular structures for those 3 steroids. While they have a few different functional groups and side chains, they all possess the 4 fused carbon rings. Phospholipids will be the last lipid group we examine. Phospholipids consist of a polar head and a nonpolar tail. giving the molecule a dual nature. As a result, phospholipids are amphipathic, meaning they have both an affinity for and an aversion to water. This property allows them to form membranes in cells.
Mm-hmm.
The head contains a phosphate, glycerol, and a polar or charged group, which makes the head hydrophilic. Attached to the head are two nonpolar fatty acid tails. Like in fats, these fatty acids can be saturated or unsaturated. Phospholipids are very important. They form the bilayer of all membranes found in and around cells. As you can see, the bilayer is created because the hydrophilic heads have an affinity for water, while the tails form an inner layer that excludes water. We will discuss membranes in much more detail during our next lecture.
Lipids include steroids. True. Lipids are mostly composed of carbon, hydrogen, skeleton. True. All the statements are true. Lipids are highly polar molecules. Lipids are not polar for the most part. Phospholipids are amphithetic, which means, yeah, right? Yeah. Woohoo, 100, you passed the quiz. Good job, Josue. Oh my god, fuck me, dude. Okay, so I'm done with section A. Section B, I have to print out my lab, which I already did. Fuck, dude, I spent so much money on ink today because I want to buy ink for my printer. So much fucking money, man. That shit's fucking expensive. Anyway. Here we have my lab printout. Complete lecture sections as best as you can. Stay long left, so please read it twice and be ready for class. If you want me to read it twice. In your last lab, you were introduced to compounds such as carbon dioxide, water, ionic salts, hydrogen, and oxygen. These are known as inorganic compounds and typically lack carbon to hydrogen bonds. On the other hand, organic compounds are usually formed by living organisms that contain carbon and hydrogen atoms. Methane, CH4, is one of the simplest organic molecules, while the biological molecules you will be investigating in this lab are quite complex. All life is said to be carbon-based due to carbon's 4 valence electrons, which can form covalent bonds with up to 4 other atoms, usually HON or another C. When carbon bonds with other carbon atoms, the carbon skeletons created serve as backbones to which other atoms or groups of atoms attach. Carbon skeletons can exist as a single carbon atom, a long chain, a branch structure, or a ring arrangement. Thus, the backbones of organic compounds range in complexity from simple methane to the benzene ring. So methane is CH4. It's simple. Hexane, it's longer chain, it's C6H14. Isopentane is C5H12, and the benzene ring is C6H6. Atoms other than hydrogen combine to the carbon skeleton. These are referred to as functional groups. Functional groups are usually chemical reactive, and the types of functional groups an organic molecule contains determine its characteristics. Some of the most common functional groups are displayed in Table 1. Here we have Table 1, hydroxyl. I don't have a fucking stapler, so I can't even staple these, and this shit's fucking annoying. So I'll just fold the fucking corner so they hold together a little better. No, that's not working. Yeah, fuck it. Anyway, extras 1. In addition to phosphate, what other functional groups does glycerate 3-phosphate have? I don't know. I'm gonna do that one in class. Complex organic compounds called biomolecules can be placed into one of four categories: carbohydrates, protein, lipids, and nucleic acid. Biomolecules are often polymers, which are chains of simple molecules connected by covalent bonds. Each simple molecule, called a monomer, is linked to the next by condensation reaction, also called dehydration synthesis, a process in which a water molecule is removed to form a bond. On the other hand, the process of hydrolysis requires the addition of a water molecule to break the bonds. Each of the four different biomolecules is composed of different types of monomers. Scientists have developed many tests using reagent substances used to detect another substance to identify the number of biomolecules. In order to perform these tests correctly, two different treatments must be completed to provide standards for comparison. The first treatment is called positive control and contains the variable being tested for. For example, if you want to find out if the substance contains protein, you will first run the test on a known protein such as meat to make sure all laboratory equipment is performing properly and to see what a positive reaction to the test will look like. The second treatment is negative control, which does not contain the variable being tested for. For example, after you run the positive test control test for protein, you also run the test on water, which does not contain protein, to make sure neither your reagent nor your test subject is contaminated, and to see what a negative reaction on the test will look like. Does that make sense? Contamination is one of the main causes of failure experiments, so it is very important to prevent contamination in the lab. If you pour out too much of the chemical, do not replace it back in the original container without speaking with your instructor. Replacing the chemical might contaminate the entire container, resulting in not only the need of disposing the entire container, but also increased lab costs because more would need to be purchased. It is also very important to use one pipette for one chemical. Using one pipette to transfer two different types of chemicals will contaminate the original container and potentially introduce trace amounts of the wrong chemical into your experiment. Also, make sure all glassware is thoroughly clean between different experiments. Why is distilled water used as a negative control for all tests? Because it is pure H2O, because it's not contaminated with anything, I guess. Then, how can you avoid contaminated reagents or other substances during this lab? By using one pipette for each chemical, and cleaning glassware. That's pretty fucking simple. Exercise 2. Draw glucose. How the fuck does glucose look? I forget. I guess we'll look it up because, just to make stuff easier on us. Okay, so we'll start with our hydrogen and hydroxide group. Oxygen, which connects this other hydrogen hydroxide group. Okay, goes here, goes back here. We have this group right here. And we have drawn it. Different types of carbohydrates can be produced by utilized by living organisms. One of the One of the monosaccharides, glucose, is the main source of energy of cells, where it primarily exists as a ring structure. Many fruits contain high amounts of sugar fructose, and our genetic material contains deoxyribose containing disaccharides including sucrose, figure 2, better known as table salt, and table sugar, and lactose, the main sugar in milk. Plants store glucose as a coiled polysaccharide starch, but animals store their glucose as a polysaccharide. Glycogen, the most common organic compound on Earth, is cellulose, a structural polysaccharide found in the cell walls of plants. Humans cannot digest cellulose, but it serves as fiber required to push down food through our digestive systems. Many monosaccharides, such as glucose and fructose, and some disaccharides, such as lactose and maltose, can be detected in solution with the reaction with a copper containing the compound called Benedict solution. These sugars are called reducing sugars. At high temperatures, the solution changes color from blue to green, yellow, or reddish orange. This chemical reaction occurs because the sugars reduce the copper ions in the solution and a compound called copper oxide forms. Fuck. Okay, so it's like this. Right? Yeah. Okay. Exercise 3B. Benedict's test for reducing sugar material needed. Test tubes, test tube tray, test tube holder, Benedict solution, 5 substances. In table 2, hot plate, 250 milliliters beaker, boiling chips, wax pencil, or Sharpie pipette. Okay, carefully read directions and note that difference between dropper and drops of chemicals. Turn on hot plate and set temperature to 500 degrees Celsius. Do not turn the knob for stir. Fill beaker with 150 milliliters of water and add 2 boiling chips. Boiling chips prevent water from boiling over. Place beaker on hot plate. Obtain 5 test tubes and mark them 1 through 5. Mark them 1 through 5. Add 1 millimeter of glucose to a test tube. Add 3 drops of Benedict solution to first test tube and swirl to mix. Record the color of the mixture and the color before heating. Column of table 2. Repeat steps 5 through 7, but replace glucose with the other substances in table 2. Water, starch, corn oil, albumin. Use a test tube holder. Place all the test tubes in boiling water for 2 to 3 minutes. Monitor the test tubes. Okay, record, turn off, empty. Sink, corn oil, gas is exposed. Place other test tubes and use test tube container. Use strainer to recover boiling chips. And return to their container. Okay, so that's going to be one of the experiments we're going to do tomorrow. The polysaccharide starch can be identified with the iodine test. In this test, iodine reacts with the coiled structure of the starch polymer, producing a deep blue-black color. Exercise iodine test for starch. Materials needed: test tube is iodine, 5 substances in table 3. Obtain 5 test tubes and mark them 1 through 5. Add 1 milliliter of starch to a test tube. Record the color of the substance in the color before iodine column of table 3. Shake the iodine bottle gently. Add 3 drops of iodine to first test tube and swirl to mix. Record the color of the mixture in the color after iodine column of table 3. Repeat steps 2 to 5. Replace starch with other substances in table 3. Example: water, glucose, corn oil, albumin. Empty contents of test tubes in sink and place test tubes and corn oil in glasses. Pulse. Okay, so then we recorded which substance listed on table 3 would be positive control, which substance in table 3 would be a negative control. So that obviously starch and water. Activity 4, lipids. Lipids are compounds that are insoluble in water but can be dissolved in nonpolar solvents such as acetone or ethanol. Lipids include fats and oils, phospholipids that form cell membranes, waxes, and steroids. Fats and oils are triglycerides composed of 3 fatty acids chains attached to a glycerol molecule by ester bonds. Bonds between the carbons in chains attached to a glycerol molecule by ester bonds. Bonds between the carbons in the fatty acids determine if the triglyceride is a saturated or unsaturated fat. Double bonds in the fatty acids result in kinks in the chains. The fatty acids of unsaturated fats, such as oils, contain at least 1 double bond, and the fatty acid chains cannot pack this closely together due to the kinks. The fatty acids of saturated fats, such as butter or lard, contain no double bonds, resulting in straight fatty acid chains that can pack closely together. I didn't understand shit of what I just read. I got completely lost. Okay. Anyway, the Sudan test that utilizes Sudan-3, a non-polar reagent that is soluble in lipids. When Sudan is added to a solution, it will dissolve into and stain lipids a bright reddish orange color. Materials needed: test tubes, Sudan-3, distilled water, 5 substances, in table 5. Sudan is highly flammable. Keep away from hot plate. Down. Obtain 5 test tubes and mark them 1 through 5. Add 1 milliliter of distilled water to the first test tube. Add 10 drops of corn oil and swirl to mix. Add 4 drops of Sudan-3 and swirl again. Record the appearance of the mixture and the initial appearance. Column table 5. Repeat steps 2 to 5. Replace corn oil with other substances in table 5. With 5 minutes, lipids are less dense than color. So look for a bright reddish orange layer on top of the water. If there is an obvious orange color, it's not a positive test. Record the appearance and the appearance after 5 minutes. Column table, empty contents, test tubes, organic waste container. Do not sink. Place a test tube in corn oil disposal. Place the other tubes in used container. Okay. Activity 5, proteins. Damn, this is gonna be a long lab, but it's gonna be so freaking cool. Proteins are an important group of molecules composed of amino acids performing a wide range of functions in living organisms. About 20 different types of amino acids exist, but all share the same general structure, as shown in figure 4, with a central carbon atom attached to 4 different groups: a hydrogen atom, an amino group, a carboxyl group, and a variable side chain that defines the proteins of an amino acid. Amino acids are linked together by peptide bonds, as the one between amino acids glycine and adenine in figure 5. As more amino acids are added, a polypeptide chain forms, which forms a three-dimensional shape due to the properties of the variable side chains in the final protein. The Burette test identifies proteins such as albumin of egg whites by reacting with the peptide bonds of the protein, the copper ions, and the regiment form complexes with the nitrogen and carbon atoms in the peptide bonds, which introduce a color change to violet. Exercise 5. Burette test for proteins. Test tubes, Burette reagent, 5 substances. It's going to be basically the same as the other one, so I'm going to just skip it to save some time. Nucleic acids. Deoxyribonucleic acid, DNA, the genetic material with all living organisms, is one type of nucleic acid. Nucleotides are the monomers of nucleic acid and consist of a phosphate group and pentose sugar, and a nitrogen-containing base. There are 4 different types of nitrogen-containing bases in DNA: adenine, cytosine, guanine, and thymine. A nucleic acid strand is formed when nucleotides bond through dehydration synthesis. This bond between the phosphate of one of the nucleotides and the sugar of another nucleotide is called phosphodiester bond. Okay, DNA molecules possess 2 strands of nucleotides that run in different directions. The phosphate and sugars of 2 strands make up the sugar-phosphate backbones, which are connected by covalent bonds. The nitrogen-containing bases on one strand form hydrogen bonds with nitrogen-containing bases on the other strand. The nitrogen-containing bases will only form bonds in certain parts: adenine, thymine, and cytosine, guanine. There is no simple test for nucleic acids, so you will not test the biomolecule in this lab. Okay. Summary. Okay, so then we'll summarize all of our results for Benedict's, iodine's, Dan's, and Burette's. Pre-lab questions. Functional groups are attached to the carbon backbone of organic molecules and determine a molecule's properties. That is true, I believe. Yeah, that is true, right? Fuck it. We'll see in lecture. Which molecules is not one of the 4 main biomolecules? Hydrochloric acid is not, because we have protein, carbohydrates, hydrofluoric acid, and then lipids. A polymer is composed of what subunits? What? What type of chemical reaction forms polymers? Amino acids are the monomers of proteins. I don't remember any of those. I'm gonna just leave it like that. And that's basically it. We just have to do the assignment for tomorrow. Like, there's like a little quiz that we take online at the very end, and that's what I'm gonna do right now. And it shouldn't take me long. Hopefully we'll be done after that. Biomolecule. Oh yeah, I have to watch the lab presentation. Oh fuck. Which is generally a PowerPoint. Yeah, I knew it was gonna take me longer than 12. Here it is. Let's open this. Biomolecules, El Centro College Biology. Describe the structure of organic compounds. Recognize different functional groups found in organic compounds. Explain the general composition of biomolecules. Contract dehydration, synthesis, and hydrolysis. Explain the importance of controls in biochemical tests. Describe the structures of carbohydrates, lipids, proteins, and nucleic acids. Perform tests to detect the presence of biomolecules. Identify positive and negative results. Cool. Organic compounds, typically found in living organisms, contain carbon and hydrogen atoms, have carbon skeletons. Figure 1. Types of carbon skeletons. Okay. Organic compounds may have functional groups. Biomolecule. Organic polymer composed of monomers. Okay. Monosaccharide examples: glucose. Polysaccharide, more than one monosaccharide linked by glycosidic bonds. They're linked by glycosidic bonds. That's one of the answers to our pre-lab questions. Is it? I'm gonna go with that, then we'll see. You know, I'll change it. And then for polymer, would it be monomer? That's what they're composed of? Amino acids are the monomers of proteins. Oh yeah, this should be true, I think. I don't even know, man, I'm telling you. I feel like I don't know shit. I feel so dumb sometimes. Magnetics test, okay, we read over that. Yup. Start boiling your water early, because it takes a shit ton of time to boil. Okay, so 0 high, so positive test is a red. Yeah, I mean I could read that while I'm doing it, so okay, so lipids, hydrophobic, contains C, NH in abundance, types of fats, phospholipids, steroids. It's a Don test. Non-polar reagents, dissolved in lipids, hypoflammable, keep away from hot plate. You'll test sugar. Positive test for lipids. It's the one on the left, right? Okay, so we're done with that. What the fuck? Now we do assignment number 4. Which should be right here. Yep, right here. Man, I should have done this way earlier in the weekend. Mono means 1. Mer means split, right? I think I wrote that down in my notebook. Let's check real quick. No, I didn't write down the root. Fuck. I have the roots here though. Mer. What does mer mean? It's not even here, is it? Oh yeah, it means part. No, stay. It means part. Mer means part. What is a bond formed by a dehydration reaction between two molecules? That is hydrolysis. Right? I did write that down. Yeah. Yeah. Right. No. What? It's dehydration, right? And that forms. Fuck it, I'm gonna go with that, and then we'll see what the fuck. A chain of monomer residues linked by covalent bonds is called a polymer. There's an isomer, which reaction that links monomer molecules together using molecule water. So it's dehydration, which is a phospholipid. I don't think I wrote that. No, see. Oh, god damn it. A long chain hydrocarbon with I'll go with that. Oh my god, this is gonna be so fucked up. That is desaturated, right? We can consider protein a polymer as it is composed of monomers. The monomers linked together from proteins are amino acids. Look at figure 1 with hydrocarbon. No, there's two. There's you and Chanty. There's 2 viewers. Hi, man. And I'm almost done. This is the last shit I have to do. And I'm probably gonna get such a low grade on this. Boy. On this little quiz here. Look at figure 1 with hydrocarbon arranged in a ring. That's a benzene. I can remember that. Reactants are chemicals that use to test into specific substance. For proteins, what reagent will you use? For proteins, we use. For proteins, we're gonna use. For proteins, fuck, I have to look through my lab. For proteins, we're gonna use albium. No, wait. Burette reagent. Yeah, it's burette reagent. 2 is so much more than 1. Of course it is. Hey, I had 4 viewers earlier, okay? But then it's starting to get late, and I'd say I went to sleep, but I did have more viewers, okay? I had double the viewers. But then I got to videos and it got boring, so people left and shit, you know? Which biomolecule would not perform a test? Will you not perform a test in the lab? Nucleic acid. You will need to be on time for next class, participate, and receive additional 2 points for this assignment. Save and submit. Okay. let's view the results. Which okay, so I got this one right. This one's wrong. It has something to do with sugar. What is the bond formed by dehydration? What the fuck? Because I got that one right. I knew phospholipid. I knew I was gonna get that one wrong. Same. I like how it just says that's not correct, but it doesn't tell me what was correct. Oh well, it's not too fucking bad. Yeah, I know, I saw. Are you done with it though? Are you done with your homework? Cause I am, I just finished right now. Look, this was my English homework. That was the first thing I did. I didn't do that on stream though, I did that before I started streaming. That's it, mate. I'm done, mate. It's time to put my stuff up, mate. Oh fuck, I have to put this back in order. Done. Kind of. Oh shit. Shit's falling everywhere. Where's my fucking binder? What the fuck? Oh, it's right here. I never took it out. I'm fucking stupid, man. I'm sleepy as fuck. I need to sleep. But you didn't even have class till fucking Wednesday. I have class tomorrow. I have to wake up at 8. Oh my god. No, I don't want to go to school. Fuck school, right? Am I right, mate? What the fuck, mate? What the fuck? Fuck. Putting all my shit up now. I need a sharpener. I have pencils but no sharpener. Phone's at 40%. Yeah, you are going to work, that's right. Shut up. Nobody cares. Boy. You should be. What the fuck are you still doing up, man? You have to wake up at fucking 5:30. No, you have to wake up at 5, not 5:30. So I don't know what you're still doing up, man. You know I'm gonna get 4 hours of sleep or less. You shouldn't be up. Mate, I worry about you, mate. Alright. We're good. We're done. I'll unplug this computer and I think that'll be it. Oh, so you got saved from doing one of your homeworks? Must be fucking nice, mate. Must be fucking nice, mate. Fucking cables and shit. You're gonna die, nigga. You need more sleep, nigga. I mean, but we already knew it. Oh my god, so like, when Luz was drunk, man, she called me, right? And like, one of the things she told me, which was funny, she was like, she started crying, man. She was like, I love you or not. And then like she's like, you're such a good friend. And then she told me, tell Jaime to stop smoking because I love him too and I don't want him to die. I was like, oh, wow. Yeah, it was just funny and adorable at the same time. She's like, I don't want him to die. Alright, mate. I'm gonna go now, mate. That was it, mate. Yeah, I know. Alright, man.